Hello, everybody. Hi, this is Saurabh from Hello Tomorrow, and I welcome you all to the first radio show in the series tackling such challenges faced by corporates while leveraging deep tech. The series is Becoming Deep Tech Savvy, a corporate journey. Today, I have here with me Merouane Debbah, Director of Mathematical and Algorithmic Sciences and Director of Lagrange Center at Huawei. He has an amazing academic profile, as evident by his professorship at Central Supelec as well. He's one of the pioneers of 5G and 4G technologies, and today we will discuss exploring the vast deep tech opportunity space with him. Uh, to engage the audience, we have two polls today, and the audience can engage with us via those polls. So jumping right into it, hello, Merouane.
Hi,
So
nice to meet
you,
you.
same here. Good, glad to have you here. So your title is Director of Mathematical and Algorithmic Sciences. This is a complex title. Can you start with explaining a bit about it, and then we go into details?
Yeah, so I'm director of the Algorithmic Mathematic Lab of Huawei, and basically, the main purpose of my task is to apply algorithms. So algorithms like a cooking recipe. When you make a cake, you need to find basically the cooking recipe behind it, and we apply those basically algorithms in various domains of the company. One of the domain, of course, is the domain of wireless, where we're applying it also to fiber optics, networking, computers and computing, and also AI, which has become a big hype.
Thank you, Merouane. So you talked about these technologies, which are very complex. These are not easy to explore. But I would ask this question in a bit different context. Why do corporates find it difficult to explore this opportunity space, this deep tech opportunity space?
Well, I mean, it's difficult and not difficult. There's many issues related to that. I mean, basically, the deep tech is quite a new hype at the moment, where everybody's trying to apply, I would say, what we call deep neural network and deep algorithms within the setting. It's been a long time that companies like us have been applying, I would say, models and mathematics to improve basically the performance of wireless systems. Today, of course, one of the big issues we're having is basically an understanding of how deep technologies have an impact on our, of course, corporate company, but also our customers. But besides that, there's also all the issues behind of explainability and being able to guarantee things outside the black box. So these are the kind of work that we're doing today to be able to provide, I would say, a full understanding of what we deliver to our customers.
So, in your rich corporate experience, um, has there been a shift from sourcing R&D to developing in-house R&D? And if so, why and how does this help leveraging deep tech?
Okay.
But I will also ask this question in a different context because I saw that Huawei is one of the biggest investments in R&D. It's one of the top six companies who is investing in R&D a lot. So how does this help in leveraging deep tech?
Okay, so our company has been having what we call an organic growth. So we don't really outsource. You have to know that Huawei is around 200,000 people. Half of the company is doing R&D. Usually the ratios that you have in our business is roughly around 10 to 15%. So that's a huge number of people doing R&D. And even if you grow up in our company, basically you have big chances to find marketing guys, people who are in other domains coming from the domain of R&D. And so basically the fact that we do in-house and R&D is extremely important because basically the survival of our company is basically on the inventions we can make today. That's the first point. Second, Huawei is also known as a very high-tech oriented company in the sense that basically I think all our customers acknowledge that. We're very focused on technology and what we can deliver to become customer centric. The amount of investment also reveals that. I mean, you said it today. We're the third investor in the world in terms of R&D investment. We're roughly around $60 billion per year in terms of investment, compared, of course, to our total revenue, which is more than 100 billion. So that's a huge number, and you have to know that roughly one third of that money is poured in what we call long-term research or fundamental research.
Can you tell me a bit more about what you mean by fundamental research? Because as such, R&D can be very different in a tech company. Fundamental research, technical research, and technological innovation. What do you mean by
Yes.
fundamental research here?
Yeah, so we have three sets of types of research that we do in our company. We have what we call business-driven research, which is more on a time frame of 6 months to 18 months. And this is more or less driven by our customers. They come with problems where the problem is defined, and then we need to solve it. The second type of research that we have is what we call technology-driven research. There, basically, we're building what we call the catalog of our company. It's roughly around a time frame of 6 months to 18 months, where 6 months, sorry, 18 months to 7 years. And there we build roadmaps and where we have reviewing internal committees which judge each year about the outcomes that we do. And then we have a third one, which we have kickstarted, which is called vision-driven research. Vision-driven research is more on 10 years time frame, where basically we're trying to do what we call science disruption, in the sense of moving forward in what we can do, in the leaps we can do. The type of fundamental research I'm talking about is more on the vision-driven one and the technology-driven one. In the technology-driven one, programs like 6G, for example, or even explainable AI are part of what we call the fundamental research, at least in their initial stage.
Okay, so I just got the results from the polls, and one of the poll was for this: what do you feel is the biggest roadblock in exploring the vast deep tech opportunity space? And one of the first answers is sourcing the tech from academia and remaining ahead of competition in doing so. So let me make this question a bit. Let me challenge you a bit more on this question. So there's a lot of competition out there, and everybody wants to source the technology from academia. So how, of course, first I would like to know, how do you source it from academia? And second, how do you stay ahead of your competition in doing so?
Okay. So first of all, I think there's nothing about sourcing out of academia. I think this is a new mindset that companies have to have now today, where basically the best talents are in academia, and we need to let them move forward and build up basically the portfolio. What we need today is to have a better understanding of what they're doing. And so I've issued a lot of investment in our lab, for example, in Paris, in putting up the level of the recruitments that we do at the PhD level, so that there's a common understanding in terms of language with academia. As you know, there's been a long-standing problem of discussion between academia and industry, where usually we speak different languages. And so for many years, we tried to bring academia to understand industry. We've made a big shift today where we understood that what we need to do is bring industry to understand academia and let academia do their work and try to see on ourselves what are the opportunities in terms of applications we can do from the breadth of innovations that academia is doing. Now, one of the big issues that academia does not have today is what we call the data. Of course, we can provide that. And I think we should act more and more as platforms, and that's what we do. For example, in the research center that I've been developing in Paris called the Lagrange, Fundamental Mathematics and Computing Research Center, we act as a platform where we let academia work within basically their own research and enable them to come within our premises to work out their own problems and move forward. I think the big step today is not about outsourcing academia, but it's much better about understanding how we could apply the different tools they are doing and let them continue in working in the way they do. We should not take off the talents which are in academia. We should keep them where they are, because that's where they can thrive. You know, whenever, and you see it, whenever we brought big shots in companies, the momentum of those big shots was always done before they joined the company. You can recruit the middle fields and bring him, for example, in our company. It wouldn't make a big change. The guy would have done all his big results before. And in fact, he would not do any kind of good results by staying within our surrounding. The continuous discussion, of course, is good. We need to be more open in providing those platforms.
Thank you, Merouane. Merouane, just to go a bit into detail on this question. So you are from both the academic and the industrial side. You are a professor in Cetron Suplec, and you have your own lab at Huawei. You're director of R&D and working on AI and 5G and 6G at the moment. So how far do these industry academic collaborations go, and how do these collaborations come into picture? So, okay, this is clear from your answer that the collaborations have to be there, and people need to be left in academia there, but there has to be collaboration. But how do these collaborations then work?
Yeah. So I think one of the big things that we didn't understand before, and now there is a big changer, is that we were asking academia to work exactly on our problems. I think we should not give them instructions on how they should work. We should understand, we should, on the contrary, provide them the plethora of problems that we have and give them the ability and the freedom to work on some of the problems they like. I think what's missing in academia is what we call the interesting problems. What are the problems? We are problem makers. We have in academia a combination of what we call problem makers and problem solvers. So of course, a big part in, as you know, is the definition of the problem. And we have many problems and very interesting problems, basically. And what we have to do today is offer those problems as a platform to the academic people and let them basically choose the one they think are more relevant, and also push them in going at a much more farther step in terms of making what we call these fundamental breakthroughs, whereas all the what we call the coding application has to be done by us. And I think this is the kind of discussion we have to engage. Second type of discussion we have to engage is to ramp up basically the level of talents that we're recruiting. I'm not saying that we don't have talents, but we need talents that speak the same language that is happening in academia. I don't think we should push academic people, because this is where the big talents are, to move forward from their mindset, to do things which are related to us. They should work on their own, and we should try to understand what they're doing.
Thank you, Merouane. But academic research, by definition, is open, whereas corporates, they need to generate profits out of it. So they need patents out of it.
Yeah.
And this brings me to back to my original question. How do you bring this technology to the corporate, or at the moment at where you are, to bring it to make it profitable for you?
Yes. I think this is our job. And I think we have very smart guys in the company today who are able to capture what is a theorem, and from that theorem, try to understand its application. This is the vision we have to have. We're the ones who have it today. We're able to connect the dots. And basically, academia should go on working on these fundamental breakthrough and make basically some scientific discoveries and move science ahead. And we're the ones trying to understand what these guys are making by continuous discussion. And then what happens is, on our side, of course, we have a full understanding of the opportunities that can be offered with these, what I call, massive tools that are being brought. And the question is that once you have a massive tool, and how you bring it is a big step. Let me give you just an example. In academia, they would invent what we call the Fourier transform, which is basically some kind of way of changing the signal in what we call the frequency domain. I will not go into detail, but there's a full theory invented by Fourier that lasted more than 200 years ago. Where you get the capture is basically from that to start building basically the algorithms behind, and that's the FFT, which is what we call the fast Fourier transform, which builds on that Fourier thing. This is something that we can do jointly with academia still. And then there's the application of that FFT in various technologies. This is where we play a role, because we understand basically the benefit for the FFT for various technologies. And this is where we make patents and we make money and we make value out of that. And for example, in the case of FFT, you have to know that in the classical deployment of 4G and 5G that we have done, a big technology is called OFDM, which is at the heart. It's called orthogonal frequency division multiplexing. It uses the basics, basically, of FFT. ADSL, which is the kind of connection that you have at home, is based on OFDM, which is based on the FFT, which is then based on the invention of the Fourier transform. So academic realm, Fourier transform, and a mixture of basically the algorithmic aspects of FFT. And then you have basically a part of the FFT plus basically the OFDM aspect which has been done. I can give you another very good example. Let's say Galois. Galois is a big mathematician which is known. He died very early in his career. He invented what we call number theory. Okay? And so basically the whole what we call Galois field is based on number theory. But from number theory to inventing codes, there's a big step. So number theory is all the things that people will do in academia. And that's good. They need to push it with the Galois field. Based on that, basically, they will be able to derive some kind of implementation with binary of those number theoretic concepts. And then we will be building the codes and error correcting codes, which will be at the heart of all the technology that we invented today. Same thing for image processing with wavelets. There's analytic, I would say, signal processing, which was invented many years ago. Then there was some breakthrough also in the academia related to wavelets. Then it was within a mixture with industry. And then basically we invented JPEG, JPEG 2000. The JPEG 2000 is based on inventions from academia. And the big leap is what we can do. And that's how we are smart. And this is where our value is to connect those dots.
Thank you, Merouane. Thank you. It's really clear. This brings me to my next question. So in R&D and innovation space, there's always a need for creating new technology. For example, yes. There's DNA storage right now, or the need to use the existing new technology, again, DNA storage, or redeveloping the existing ones, let's say reshaping the core What is the origin of need? It comes from a futuristic vision of your research, or it comes from the market, and if so, how does it go?
So it's a combination of both. You have to do, when you do research, you have what we call uncertainty research and certainty research. Certainty research is based on what we call product development. It's mostly led by engineers, and basically we know what we to do. In general, it's problem of complexity, and which we have to do the reduction of that complexity. There, basically, the margin of what I call breakthrough is quite small, in the sense that in general, it's improvements, it's quite important, and in general, you're quite tied basically to very short markets on which you need to deliver. The second thing is more around uncertainty research, and where basically this is where you get the 10x, 100x leap in terms of rate, in terms of complexity, in terms of making the world greener. And basically, this is where the breakthrough is going to be making, and this is where you're not going to be having just an impact for your own company, but having an impact for the whole industry. The notion of ecosystem is very important here, because as a company, you don't necessarily need just to grow by yourself, but you need also to grow all the others with you. Everybody's going to benefit. Being alone in a market does not make sense. And so one of the reasons we're pouring this vision research and we're trying to make this breakthrough is that because it impacts not only our company, but it impacts the whole ecosystem. And when you impact the whole ecosystem, you get much more from impacting just yourself, because at one moment you cannot grow. You always grow with your peers. Take a professor at university. A professor on his own can do research, but he can start growing even more when he has students and the interaction with the other peers. That's what makes you even grow faster and go farther. So one of the reasons also that we are doing basically this, I would say, more research around theoretical breakthroughs, because you had engineering optimization, you had technological optimization, you now have technological invention, and now you have what we call theoretical breakthroughs, which are also mastered. Because all these pieces, when they gather together, of course, they have an impact on all the different lines of our company.
This brings me to my next question. Thank you, Merouane. So you talked about developing new technologies in house, but when you develop new technologies in house, this also requires upskilling your existing employees or new skills to be developed in the employees that you have. So how do you do that? How do you approach this? Or how do you, you already answered part of this, because I wanted to also ask you, how do you bring the best and brightest from academia to R&D? But this is something that you don't want to do. But how do you upskill the employees that you already have?
A very good question. A very good question. And this is, I think, the most complicated. So first of all, a company like us survives only with talents. So of course, the talents and the recruitment is extremely important. Now, of course, once you have talents within your company, they need to grow, and they need also to be skilled with respect to the changes. The changes in the ICT industry, which is our industry, are quite fast. And here, of course, you have a couple of ways of doing it. One way, of course, is moving the people to new domains, okay? Which basically is something in general that can be done for young people. Young people are very attracted by changes within their, I would say, career on a 3-year time scale, and moving to other domains where they ramp up skills. The other is the amount of training that we're providing to our collaborators. The amount of training is extremely important, and the amount of training is also done with the fact that we're heavily recruiting also people who are PhD students with which they can interact. In France, we have a very good system called the CIFRE, PhD students. So CIFRE is not only meant just to train students, but it's also a way to train basically our own researchers. They get close contact with university through the PhD student. As you know, in general, PhD student CIFRE spends 2 days, 3 days a week at university. This feeds up our brains with a lot of knowledge and a lot of fundamental knowledge about what's happening. So we get up the new skills and the new information which is happening through the PhDs and the collaboration. So collaboration are extremely important also within a research center. You can't build a research center without an ecosystem which is strong, with very strong universities with whom you have a lot of links in terms of contracts. Otherwise, you just do it on Mars. And if you build a research center just on Mars, then after a certain number of years, it fades up. So what I'm saying here is that there's 3 types of ways. Either you move people to other, I would say, types of domains. That's one. Usually it's much at the younger level where you can do this because they're quite attractive by changes. Second is the amount of training you can pour in a company, and we're doing it a lot. And the training, of course, goes also with all the publications around. And the third one is the huge amount of collaboration and contracts that we've been establishing with our ecosystems since the beginning of our lab. I think the amount of collaboration that we've been pouring around with universities here is quite huge compared, of course, to the workforce that we have. And I think this is also what's bringing more and more basically kind of new skills that we require and train our research scientists.
Thank you, Merouane. I have a question on the same thing. So, how do you approach a multidisciplinary training? Basically, again, I go back to the example DNA storage. So, DNA storage is now a link between molecular biology and ICT. How do you approach this kind of training? This is really tough to approach.
Yeah. So the kind of people that we tend to recruit, we don't recruit basically people who have specific, I would say, knowledge or specific skills. For example, in the lab in Paris, we try to think people have more fundamental background, because we know that once you have that fundamental background, with a bit of training, you can then a bit learn whatever disciplines you want. And I think this is quite important, where we saw a shift many years ago of a lot of industry players trying to get from universities very skilled people with very narrowed skill. And after a couple of years, they got stuck with these guys because they didn't know how to ramp them up. Whereas if you take a guy who has a very strong, I would say, fundamental background, meaning mathematics, physics, chemistry, and then basically you incorporate him and then you train him, that goes in. Now, the question you can ask myself is why we're doing it and not others. Well, as you may know, is that our company is not in the stock market. Huawei is not a stock market company. It's owned by its own employees. So we have a bit of visibility where once our employees come in, and this is one of the reasons I joined Huawei, basically, you have a long-standing career where you can stay in the company in terms of progressing, because you're not induced by the, I would say, changes that can happen in the stock market, and the turnover is quite low.
Thank you. But I'm gonna relate it to the question that I asked you before, relating to investments in by corporates in the R&D. So all these trainings, they require heavy investments. They require a lot of expenditure. But how much of this actually translate to innovation potential of the company? How do you determine this? Because this is a big thing. At the end of the day, company has to sell. Company has to make a profit.
Yeah. So that's a good question. I think at this stage, basically, it's hard to quantify exactly the amount of money we have in training and in terms of return that we get. What we know is that we're trying to get the best people and keep those best people by giving them incentives to stay. And how you keep incentives to stay is by, of course, ramping them in skills and putting them in interesting projects. Now, of course, the amount of investment that we're doing, I think we're the third one. I think Amazon is first and Microsoft is second and Huawei is third, roughly around the 16 billion, showcases that, of course, with this huge amount, you can't just do R&D. You have also to train the people, let them go to conferences, publish papers, and all these things. Now, the exact numbers of how you get, I don't know. But however, it's like a startup. In general, you pour a lot of money, you build up a catalog, and once you build up a catalog, there's some successes, there's some failures, but at the end, the number of successes, you get more return than the number of failures.
Thank you, Merouane. So technology, I mean, as such, is not generated in an instant. The roadmap goes from discovery to invention to innovation. There's a role of academia, there's a role of researchers, there's engineers. Can you tell a bit more about this cycle, the innovation cycle?
Totally right. I mean, it's a long process. I mean, if you look at what I call here fundamental research, applied research, and engineering research, when you look at new discoveries, we're talking about Einstein. It's 10 to 20 years. I mean, we're talking about theory, and that's what you're going to do. When you're talking about applied research, then it's a 5 to 10 years time frame. We're talking here more about Tesla, in terms of mindset. And then if you look at engineering research, you're talking more here about Steve Jobs, meaning looking at something, looking at how you combine it to make the perfect iPhone. And so, of course, you need in the company a blend of all these things. Now, in general, the kind of fundamental research that is done is mostly sponsored through gift funding, through chairs, by us, through academia. We don't have basically the kind of mindset of people who can do fundamental research, because you need some kind of total risk, which in general is not the kind of mindset of people who want to go to industry, and also the kind of total freedom of mind that people would like. And so this is the kind of things that we do, and we like it, and we want to keep the people over there. Then applied research and engineering research can be done in-house, in the sense that we have programs which are 5 to 10 years for the Tesla type of guy, and we have also the the kind of research on the 2 to 5 years research, which is a time frame, which is let's say the kind of Steve Jobs mindset.
So I asked in a poll, what, according to you, is the most risk-oriented part of the innovation cycle for a deep tech product? And the options that came at the top were theoretical discovery or theoretical breakthrough. How much do you agree with this? Out of the options were other options were theoretical breakthrough, commercial application, technical readiness, technical innovation, and technical invention.
Yeah, I think it's totally right. In terms of risk, let's say the kind of new theory discoveries is the most challenging. It's not even challenging in terms of research. It's also challenging in terms of recruitment of people you can get for that. Why? Because the kind of, I would say, reward that the guy gets in general is a long-standing process. And so you need also to have the right HR, human resource, basically, capability and system to judge these guys. Now, academia has put into place a sort of way of judging people where basically, even though they don't get any kind of success during 10 to 15 years, they can still get progress in their career. In industry, this is the kind of things that, in terms of mindset, where people would not come because they would like to get a reward after a couple of years staying in a company. And so I think the kind of system that has been put place in academia is the right one to be able to push new discoveries. And I want to insist on something very important, is, as you know, we always tend to think that discoveries or new theory discoveries, when somebody did research for many years and didn't find something, it's a failure. It's not at all a failure. And also in our company, we praise that. It's not a failure because you learn from your mistakes. And even if you made something that was not intended for something, it turns out, and I can give you many examples within my lab that happened, that when after a couple of years, what we tried to do, improve for wireless, was a total blocking point. And then my guys in optical, a couple of years after, realized that what we had done in wireless, which did not work, could work exactly for that type of medium. So you need also to have that mindset that whatever you do, you should be able to document it, put it aside, wait a bit of time, and then after a couple of years, you'll get some guys picking it up for total different applications. And you'll see that many cases, that's what happened in the invention of research. People were blocked in one domain, and somebody just saw that what they did there, which was not working, it was just not the right problem for which you were trying to intend that solution. And the new problem just appeared, and this is where the breakthrough happens.
So basically reusing a solution that was created for something else at someplace else.
Exactly. So because we tend to think that failure is just the fact that it didn't work somewhere. If you did the right work in terms of developing the right solutions, it doesn't matter if it doesn't fit for that problem. There will come a time where you'll find the right problem to which you can apply that solution to.
Thank you, Merouane. To end the show with, I will ask you quite a cliche question. So we have seen companies going from 3G to 4G to 5G, and I mean 5G is gonna come soon, and to 6G. And I suppose you have been involved in 4G and 5G. Can you tell us a bit in short the challenges that were faced and how you overcame them?
Very good. So these G that we're talking about are what we call generations for cellular. 2G was mostly related to what we call mobile for voice. 3G was mostly related to mobile for data. 4G is mobile for internet. 5G is mobile for things. And 6G is intended for mobile for machines, how you connect machines. The new kind of opportunity that we're seeing here, each one has challenges. If I take the 4G one, it was mostly about having what we call a full IP-based system in terms of how you build it, in terms of connecting things. And just to give you an example, bringing voice in 4G is a big issue because voice is not a technology in 4G, but it's an application. It's like voice over IP. And imagine you're trying to build a mobile system based on internet, and for which basically you need to pour voice, and where 2G works better because it's voice and a technology better than 4G in terms of voice. Data, of course, is great. 5G, we had a lot of different, I would say, challenges. One of the challenges is that when you start having connectivity for things, you have a lot of energy requirements that you need to comply with. It's extremely hard. You need sensors that date for more than 10 years. You need a lot of latency for autonomous cars. That was extremely hard to tackle. And you need extremely reliability with something that you don't have when you make a call. Sometimes when your call does not pass, it's okay, but on a 5G network, imagine you're connecting a car and then for 1 minute the connection stops. There's an accident. So we needed to solve all those pinpoints. Today, within the realm, that what we do is even more complex because we're embedding those things with what we call machine learning algorithms, DNN. And we're trying to find the right protocols to connect intelligence between them. And connecting intelligence is not anymore with the human behind. You have systems which can create their own protocols. Imagine all these things. And the question is, how are you going to connect all these different, I would say, type of autonomous
You mean
systems?
connecting AIs?
Connecting AIs, yes. We need to build the infrastructure, the network, the wireless infrastructure that can connect AIs so that they can talk to each other. And this is, I think, one of the biggest challenge which is facing us in the next years, because already in the AI realm, we have difficulties. Now imagine bringing the communication of AI between AIs. It's another step.
Thank you, Merouane. So to conclude, you would say that ecosystem is the biggest resource for corporates while leveraging deep tech and the application and its applications.
Yeah, I think as an example, I can give you our example. Why are we in Paris? We're in Paris, and why we're doing mathematics? Because we made a long survey in terms of understanding where we could work in the best way for doing mathematics in the world. In fact, there's two places where you can do that. That's in Paris and that's in Moscow. Why? Because the best mathematicians in the world are in Paris and in Moscow. And same again, if you ask me software, I would tell you also places where you can do that. And the ecosystem is very important because it's through discussions and basically through interactions that you can build up basically some new discoveries and also try to connect the dots. Connecting the dots is very difficult. You need a certain mindset of people, and the mindset of people you can find for connecting the dots are the ones you find in industry.
Thank you, Merouane. It had been really a pleasure. Thank you, everybody. Thank you, Merouane.
Thank you again. It was a real pleasure to be with all of you, and see you next time. Take care.
Bye bye.
Bye.